Good morning, everybody. Today we are going to work on objective 2.3 for lines. So we will talk about everything about lines in this case, okay? So that's 2.3 and we are talking about lines. Slope of lines. How are we going to graph the lines, the equation of a vertical line, point slope form of a line, horizontal line, slope intercept form of a line, and parallel and perpendicular lines equations. So a lot. So let's start with calculate and interpret the slope of a line. What is slope? Okay, consider the staircase, this staircase right here. Each step contains the same horizontal run and the same vertical rise. So that's rise and that's run. The ratio of the rise to the run, called slope, okay, is a numerical measurements of the steepness of the staircase. So you see this, the ratio of the rise to the run, called slope, and it's a numerical measure of steepness of the staircase. So what is the definition of the slope? And the notation for the slope is m. Okay, this is I don't know why they use the notation m for the slope, but that's what it is. So slope is m. The definition is it's supposed to be change in y values over change in x values. You know, change means you subtract, okay? Now, I'll show you how do we get the slope from the graph. For example, I pick 2 points. I have to draw a graph first before I pick points. So I'm gonna draw a line, and this line is going probably up here. Okay, so here is my line. You can pick 2 points, for example this, and the point that exactly going through the corner of these squares, the graph paper squares. So I pick because if you pick something over here, then it's going to be a decimal or a fraction, and it will mess you up. So pick 2 points, any 2 points on this line, okay? It doesn't matter, I just pick these ones. You can pick this and that, you can pick any other, the slope is going to be the same. So I pick 2 points. I would say this one is x1 right there, and this is my y1. Okay, now this is my x2, for example, and this is my y2. So I pick 2 points. This, if you guys pay attention closely here, I'm going like this, right? I shouldn't be going in this way. Okay, so I'm rising right there. This is a rise, and I'm running in this direction. Okay, so that's the run, and that's the rise. And I'm rising and running because that's a positive slope. Okay, it's a positive slope. That's why I'm rising and I'm running. If you see, I'm rising and I'm running to the right. So that's how you're supposed to pick 2 points. You rise, you run. If you have like undefined slope, so I'm going to draw undefined slope, which is, for example, pick this point. This is my x, just pretend this is 1, 2, 3, 4, 5, 6. That's -6, right? So this is x equal -6. So my defined point is going to go, my defined slope is going to go something like this. So that's this line is undefined slope. Okay, so that's undefined slope, which means this is x equal -6. And you can tell it's x equal -6, so that's undefined. Okay, so we also use the vocabulary word for the slope is average rate of change, so don't forget that, average rate of change. You know, this means change in y and change in x. This triangle means change. So you can pick, like I said, if you're looking for the graph on the, if you're looking at slope for the graph, then you pick any 2 points for the linear graph, actually. Then you're going to pick 2 points, you're going to rise and run if it's a positive slope. If it's a negative slope, then you fall and run, which we will do next. Okay, so this is how you do slope of the line, okay? Now, let me give you an example before we go for the positive and negative. Here is the example. I have two, the question is find the slope, and I have 2 ordered pairs. I have 2, 8, and I have 6 and -3. Now, you can use either your formula equation, this one, or you can graph these 2 points up here, and you can do, if it's a negative slope, then we're gonna fall and run. If it's a positive slope, then we're gonna rise and run. Either way, that's how it's gonna happen. So if I'm graphing this and I'm not using that formula, the one I had, I'll use both, okay, and I'll show you. So let's graph. Right now I'm not using the equation. I'm graphing these 2 points, 1, 2, and 8. 1, 2, 3, 4, 5, 6, 7, 8. This is 2, and this is 8. Okay, I got 1 point. 6 and -3. So 6 is x. 1, 2, 3, 4, 5, 6. And -3, 1, 2, and 3. And you know that's -3. So I have 1 point right there. I have another point there. Do you see it's gonna go, the graph is, you connect these 2 points. You connect these 2 points right there. Now, do you see this? It doesn't look like a positive slope because that one was positive slope, if you guys see that. I mean, right there, that's a positive slope, right? But this is negative slope. So if the slope is negative, right, then you are actually falling and you are running to the right. So how do I fall? You know, I'm gonna pick any 2 points again. For example, I'm picking just this point and the point right there, and I'm falling. So if I fall, watch, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm falling 11. And I'm running 1, 2, 3, 4, and I'm running 4. But since it's a negative slope, I have to have that sign, -11/4. So I'm falling and I'm running to the right, and it's 11/4. In case you don't want to graph, you don't want to count all these boxes, so I can do equation. Like I have to label them. This is x1, y1, and that's x2, y2. And guys, it doesn't matter which one you pick, x1, y1, and which one you pick, x2, y2, but you do know in order pair this is x and that's y. Okay, so let's use my equation. M equal y2 minus y1 over x2 minus x1, and I'm showing you both ways, so it's up to you whichever you want to use and look easier. So I'm going to plug in y2, m equal, my y2 is -3 minus y1 is 8, right? y1 is 8, and my x2 is 6, and my x1 is 2. let's do that. It's going to give me 8, 9, 10, 11, negative 11, and this is going to give me 6 subtract 2, 4. I got the same answer right there. So 2 different ways. It's your choice how you do that. Okay. So let's do a few more examples. Okay. The question is right there. They said draw a graph of the line, like I'm going to draw a graph that contains point 2, 1 and has a slope 3/2, and that's part A, okay? And part B said -5/2. So I'm gonna graph both of these. I have to graph with 1 point, and this is negative slope and that's a positive slope. So we're gonna use different colors so we can understand which one goes where. Okay, so point 2, 1. Let me fix this. It has to be exactly right there so we don't mess it up. Just a little bit more. There you go. Now 2 and 1. So that's my point 2 and 1. Okay, 2 and 1. 1, 2, and that's 1. That's my 1 point, and this is part A. I'm gonna do part A is in red color. Okay, so right there. So this is 2, 1. Then the slope is positive, right? So if the slope is positive, you're actually rising 3 and you're running to the right 2. So I'm rising 1, 2, 3, and I'm running 2 to the right, 1, 2, and I'm counting these boxes if you pay attention, guys. So that's my slope for this one. So let's draw a line, and let's try to draw a straight line. Okay, so this is my line for this. So let's extend that just a little bit. There you go. That's my one graph. There. Then I have to graph this one, and I'm going to use a different color, and this time for the B I'm using a green color. This is -5/2, and you can tell the slope is negative. So I have exactly the same point, 2, 1. Okay, so the 2, 1 is going to be the same, this one, and I have a negative slope, so which means I am going down 5, like falling 5 and running to the right 2. So falling 5, 1, 2, 3, 4, 5, and I'm running to the right 2, 1, 2, and this is my another line. So let's draw that line too. Okay, I think I clicked it, maybe. Okay, so let's draw a line. Okay, there you go. So let me extend that one so we can have a good idea. There you go. So this is my part B. Do you see that's a positive slope and that's a negative slope, and they are going in different directions? So that's how you can draw or graph these points. Rise and run and fall and run. Okay, now let's talk about point slope. I'm going to talk about point slope form of an equation of a line. So point slope, which means I have a slope, right, M, and I have a point XY. You know, XY order pair, we call it's an order pair. These are coordinates. This is also called point. So different names, different vocabulary words. So what is my point slope? Okay. I have a point slope equation which is y minus y1 equal mx minus x1. You see x1 and y1, these are my points, and m is my slope. So this is called a point slope equation. Okay, so let's do an example for the point slope, and I have the word problems all on the right side, so we can do that. Find the point slope. Here we go. Point slope form of an equation of the line with slope 3, which means that's my m, containing the point 1 and 0, which is x1 and y1. Okay, because you know point slope is y minus 1, and you guys have to memorize this. Equal, okay, never mind. Let's try. Y minus y1 equal mx minus x1. So memorize that. That's a point slope. Point means you have a point x1, y1, and you have a slope. So you will remember that. So I'm going to write my equation y minus y1 equal mx minus x1. So here we go. That's my point slope. And all I have to do is plug in the values for it. So y is going to stay as a y. y1 is 0. Slope is 3. X stays, x1 is 1. So that's my point slope equation. You can also solve for y if you want to. Otherwise, you can leave it alone. You can just leave this as a point slope. If you want to get the y by itself, then it's going to go y equal. You have to distribute that. So it's going to give me 3x like this, and then negative 3. You know the 0 disappeared. So you can do either this way or you can do either that way. Okay, so that's the finding slope, point slope form of the equation. Now, if I want to graph this, okay, if I want to graph that, you know you cannot graph, you can graph, you have a point and you have a slope, and the slope is positive, so you are rising and you are running, okay? So if I'm graphing this, I will use a graph right there. I'm going to make it smaller and on scale. Okay, here we go. So if I'm graphing this, we know the point that we had was 1 and 0, right? So I can do 1 and 0. This is 1 and 0 right there. And the slope is 3, which means I'm rising. You can do something like that. So that's rise and that's run, okay? If you can do this, like make a fraction. So I'm rising 3, 1, 2, 3, and I'm running 1 to the right, which is right here. And then you can draw a line. It's not on scale, but here we go. It's not a straight line. That's how the graph is going to look like for this equation. You know this is negative 3 is my y-intercept, and that's your slope. But this is different. We call this something different, which I am going to show you in the next one, okay? So let's try another example. Find an equation of the horizontal line containing the point 2, 3. And since you can tell, they said horizontal line, right? So let's use a different color. Equation of the horizontal line containing point 2, 3. So I'm using the same coordinate plane 2, 3. This is, you know, that's x, that's y. So 1, 2, and my y value is 3, 1, 2, and 3. This is the point I'm getting. Okay, so if this is the point I'm getting, or maybe let me draw it here, okay? I don't want you guys to get confused with the other one. So let's try this. 2 and 3. 1, 2, and 3. 1, 2, and 3. Here is the point. Then they said horizontal. Horizontal, of course, horizontal is going to go like this, right? So that's my horizontal line. Now, if you guys pay attention, this is a horizontal line, and it doesn't matter if I plug this in, and if I'm looking for an equation like they said in equation, so it's a straightforward equation, because look at this y value, 1 2 3, that's going through 3, right? And the x value is 2, which we have already here, so 2 and 3. So if I want to plug this in, and in the point slope equation, because they are asking for equation, so I have to give them an equation form. So my y1 is 3. Do you see what is the slope of this line? The slope of this line is going to be a 0, because it's a horizontal line. If you guys remember, I did here, I said the vertical line slope is undefined. The horizontal slope is always 0. Okay, so the slope is 0. And this x1 is 2, which is right there. So let's fix this around. I have y minus 3. I have to distribute. When I distribute, 0 times x is 0, 0 times negative 2 is 0. So everything is 0 here. And I have to add 3 both sides. So I can get y equal 0 plus 3 is 3. So the horizontal line equation is y equal 3. Now, if you guys don't confuse yourself big time, the x graph goes vertical. Okay, like this one, the one I did. This is x equal negative 6. So the graph I said is for the x is always vertical and the slope is undefined. The graph of y equal is always horizontal and the slope is 0. Okay, let's try y equal mx plus b, the slope intercept form. Like I said, I'm going to show you another one, slope intercept form. So what is slope intercept? Slope intercept form is y equal mx plus b, and this is very popular one. I like that. So find the slope. For example, this is y equal mx plus b. Okay, what is this b? This is y-intercept. Y-intercept where the graph crosses the y-axis. Okay, that's where y-intercept. What is this? That's a slope. Now y-intercept as an order pair, the x is always 0 when you have a y-intercept. So this is y-intercept. For the x-intercept, I'm just showing you what x-intercept looks like. The order pair is when y is always 0. Okay, let's try some questions for this. Find the slope m and y-intercept b of the equation this. Graph the equation. Now, if you guys really closely pay attention to that. Now, do you see this one does not look like slope intercept, because you know they are asking for slope in intercept. You cannot tell what the slope is and what the y-intercept is unless you change this into y equal mx plus b, which is my slope intercept form of the equation, like y equal mx plus b. So I have to change this into y equal mx plus b, like get the y by itself, isolated, and move everything to the other side of equal. Then I'm okay, I can tell that's my slope and that's my y-intercept. So let's do that. Isolate y, and I'm putting y in the box. Do not remove this 3 first. Always do the rest of the stuff, move to the other side of equal, then get rid of 3 last. Okay, so I'm going to subtract 2x because this 2x is jumping over the equal. Every time we jump over the equal, that's opposite operation. So subtract 2x. Cancel, cancel. I'm left with 3y equal, and you know these two are not like terms, so I'm going to leave it. Again, box the y. Now I'll get rid of 3, which is dividing, because 3 and y multiplying. So opposite operation is division. And you divide and multiply everywhere. So I got y equal negative 2/3 x plus 2. I simplified. So now can you tell which one is the slope? This is my slope. M equal negative 2/3. What is my y-intercept b? It's positive 2. Now they said graph this equation. So I am going to graph that equation using my graph. Okay. Here you go. Let's graph. Let's move this just a little bit more. Okay. Now, how do I graph this? Remember that. Always remember this, okay? I'm going to use a different color. Remember this. You're going to graph in y-intercept or b first. So, graph b first. Then you're going to graph slope second. Remember always that. So I'm going to graph 2 first, and 2 is positive, and this is y-intercept. Like I said, it's a y, the graph that crosses the y-axis. So 1, 2, and it's a positive y, so it's above the x-axis. This is positive y. The slope is negative. Do you see that? So what am I going to do? I'm going to fall and run to the right. So I'm falling. How many times I'm falling? 2 times. 1, 2. How many times I'm running to the right? 3. 1, 2, and 3. So connect the dots, and that's my graph right there. So I can move this just a little bit up here. No, not that much. There. And I can extend that. There you go. So that's my graph. And you can tell it's a negative slope. I'm falling and I'm running. Okay. And you can tell if I pick these 2 points, I'm falling 2 and I'm running to the right 3. You count these boxes. Same thing. Okay. So that's my y equal mx plus b. Okay. Let's try this example. According to that example, find an equation of the line. When they are asking for equation, you have to give them y equal mx plus b every time. I always, when I see the word equation, I just, the y equal mx plus b click in my head. So equation, y equal mx plus b, remember that. So that's my y equal mx plus b. I always write this on top of the equation. The line containing the points 3, 2 and negative 3, 4, graph the line. Okay, so let's find first all of this. So y equal mx plus b. But you do know you have points, right? So I can, and you can also use, by the way, the other equation, y minus the point slope. It's your choice, whichever works for you. Okay. Because the point slope, when you plug in all the values and you solve for y, you will end up y equal mx plus b. So it's okay. So let's try use the point slope, and we will change this to y equal mx plus b at the end, because that's what we need for the equation, right? So I can use point slope. Now, what is the point slope? I need a point, and I have 2 points, so I can pick any one of these points and plug it in for x1, y1, and it's your choice. Either pick negative 3 and 4 or pick 3 and 2. But we have to look for the slope first. So let's get the slope. And for the slope, if you remember, we have a formula, y2 minus y1 over x2 minus x1. So I'm going to use my formula to get the slope, and then we'll graph all the stuff. So I'll label them x1, y1, x2, and y2. My y2 is 4. My y1 is 2. My x2 is a negative 3, and my x1 is 3. So this is 4 subtract 2 is 2, and that's negative 6. So simplify this. Always simplify the slope, negative 1/3. So what is my slope? It's negative 1/3. x minus, and I have, okay, let me erase that. Can I use this? Why not? Okay, I want to get the space cleared. So I have negative 1/3, that's my slope, right? So which I plugged it in. Then I have y minus, which order pair or which point should I pick? It does not really matter. But I'm picking 3 and 2 because they are positive and I like my positive numbers. So what is the y one? It's 2. What is the x one? That's 3. Now let's solve this and we will end up y equal mx plus b because that's what we need. So let's try. Distribute first. Y minus 2 equal negative 1/3 x. Negative times negative is positive, and 3 times 1 is 3, and 3, so this will turn 1, right? Now I have y minus 2 equal negative 1/3 x plus 1. Now move the 2, add 2 because 2 is jumping over the equal, so opposite operation is very important, in plus 3. So this is my y equal mx plus b. Now I can graph this easily. Let's move this, and I'm graphing that using my coordinate plane right there. Can I move this here? Okay, let's graph. You remember we graph this first. Okay, so plus 3, 1, 2, 3, here is the dot. And the slope is negative again, so I'm going to fall and run to the right and fall. So fall, how many times I'm falling? 1. 1. And how many times I'm running to the right? 3. 1, 2, 3. Now you can connect the dots. And this is gonna give me that. Here we go. So that's my graph, and it has a negative slope. Okay, so we did so many of these things. So let's do the general form of the equation. What is a general form of the equation now? General form of the equation of the line. General form is ax plus by equals c. A, b, and c are real numbers. A, b, and c are real numbers. Okay, let me give you an example for the now. Look at the equation. Example, graph the equation 2x plus 3y equals 6 by finding its intercepts. I'm graphing it, but they said they never said which method. They never said use slope intercept form. They never said to make a table. They said finding its intercepts. And since I explained these intercepts right there, this is y-intercept and that's an x-intercept. So let me do it one more time. X-intercept means always draw order pairs when they talk about x-intercept and y-intercept. Okay, the way I'm doing right now, this is x-intercept, which means y is always 0. X could be some number, but y is 0. Y-intercept means when x is always 0 and y is a real number. Okay, so I drew this, 2 of those. Now let's figure it out. First, let's find the x-intercept. So 2x plus 3y equals 6. I'm using that equation to find intercepts. For the x-intercept, y is 0. So I'm going to keep the 2x as a 2x because we don't have x. And we have a 0 for y, 6. So you know it's got 2x equals 6 because 3 times 0 is 0, disappeared. So now to get the x by itself isolated, 2 has to jump over the equal. We use opposite operations. So x equal 3. So what is my x-intercept? 3, 0. Perfect. Now let's find the y-intercept. Again, 2x plus 3y equals 6. Y-intercept means when the x is 0. You see, x is 0. That's why I like to write this before I plug them in. So 2x is 0 plus 3y equals 6. 2 times 0 is 0. Then I'm left with 3y equals 6. You divide 3 both sides because I need to isolate my y. Simplify 2. So what is your y-intercept? It's 0 and 2. So you got 2 order pairs. You can graph them easily. You know you have 2 points right there. So let's graph them here. Move that up there. And it should be perfect. Okay. So let's graph this. 3 and 0. 1, 2, 3, 0. 0 and 2. Y is 2, okay? So x is 0. 1, 2. Now connect the dots. Connect the dots and I got the graph. And it's a negative slope, you can tell, because I'm going to fall and I'm going to run to the right. Okay. So that's what we got so far there. Okay, let's talk about parallel lines and perpendicular lines. So let's do parallel lines first. Parallel lines. When two lines do not intersect, that is, they have no points in common, they are parallel. For example, I'm just gonna draw a rough graph. These two lines, like line 1 and line 2, they are parallel. And they are not intersecting, and there are no points in common. Like they don't have any point of intersection if they're not intersecting, of course. So they are called parallel lines. Now, if you have parallel lines, their slopes are always equal. Like the slopes are equal, and they have different y-intercepts. Y-intercepts, you know, y-intercepts means B I'm talking about, are different. And you can tell from here, the y-intercept for this one is here, the y-intercept for this is here. Or the y-intercept means when it crosses the y-axis, right? This is my y-axis, that's my x-axis. So do you see this? They are different, but their slopes are the same. They are positive slopes, right? So that's what it means for the parallel lines, okay? Now, let me give you an example for the parallel lines. For example, I have line 1, x1, I'm sorry, not x1, x plus 2y equals 6, and I have, no, I don't want that. It was supposed to purple. Okay, it's not changing, but that's okay. Line 2. Line 2 is 2x plus 4y equals 0. That's line 1, that's line 2. So let's figure it out. We can show them that these two lines are parallel or if they are not parallel without graphing them, okay? I'm not graphing them. So what we can do, Let's change this to, how do we, what is the other way without graphing that we can tell these are parallel when the slopes are equal and their y-intercepts are different? So how would I know their slopes are equal? Because they are not in y equal mx plus b form. So I have to change them into y equal mx plus b. So again, isolate y up here. So move the x. So I have 2y, subtract x both sides, okay? Cancel. I'm left with 2y negative x plus 6. Divide by 2 everywhere, each term. So y equal, you know there's invisible 1, negative half x plus 3, you simplify that. So that's my y equal mx plus b for line 1. Let's do line 2. Again, isolate y, get rid of the 2x first. Cancel 4y equal negative 2x, 0 disappeared. Again, isolate y, divide 4 everywhere. So I got y equal negative half x because I simplified that, right? 1 into. Do I have a y-intercept? No, I don't. If I don't have a y-intercept, it means it's 0. Okay, so look at this. The slopes are exactly the same. M is equal negative half. M is equal negative half. So the slope is exactly the same. If the slopes are the same, the lines are parallel. And their y-intercepts are different. This one is 3. That's a y-intercept B. This is y-intercept B. There was not there. So we can say it's a 0. So the lines are parallel. Okay. So let's try this example. That's a word problem. Let's go there, move that just a little bit, not that one. Okay, now find an equation of the line. Find an equation of the line. Find equation of the line that contains the point 1, 0 and is parallel to the line x plus 2y. Again, the word equation. Remember guys, if I said the word equation, then it means I'm talking about either start working on the y minus y1 mx minus x1 or y equal mx plus b or mx plus b. Either one, it's your choice. Okay, so my equation is x plus 2y equals 6. Now, how would I know the lines are parallel? Because their slope's supposed to be equal, right? Both of the slopes supposed to be equal. I don't know what the slope of this one is because it's not in y equal mx plus b. So let's change this into y equal mx plus b first. So I'm going to keep the 2y and subtract x both sides, right? So negative x plus 6. You divide 2 both sides and then I'm left with y equal negative half x plus 3. So y equal mx plus b, and I can tell this is the slope is negative half. So if the lines are parallel, the other line that they want me to find the equation for the other line which is parallel to this, but the slope is going to be the same, right? So let's use point slope formula and then we will end up changing into y equal mx plus b. Y, the point is right there, which is 0 is y, slope is going to stay the same, negative half, x minus x1 is 1. So y equals 0 disappear. I'm going to distribute negative half x, negative times negative is positive half, and this is x. So you can check their y-intercepts are completely different and their slopes are exactly the same. The lines are parallel. This is the equation of the line that they want me to find. This one was already given. I just changed it to y equal mx plus b, right? Okay, so let's talk about perpendicular lines now. Perpendicular lines, when two lines intersect, okay, perpendicular lines. I'm going to draw perpendicular lines, they intersect each other. For example, here is the line that they are intersecting each other. at a right angle, like when they intersect each other, they are making right triangle, like a 90-degree angle. Then we call them, they are perpendicular. Now, how do I know? Like I said, the lines are parallel. If the two lines are parallel, then we can tell they are parallel. But if the graph is not there and I just have an equation, like for example, equation like these, then it means I have to equation change into y equal mx plus b and then find if their slopes are the same, then I can tell the lines are parallel. But what do we do for perpendicular lines? If I'm not talking about a graph, I'm talking about in equations, right? So the perpendicular line means the slopes supposed to be opposite. Opposite means if one is positive, the other one's supposed to be negative. Opposite and reciprocal. Okay. If line 1 slope is -3/2, then how would I know line 2 slope is going to be if they are perpendicular? 2/3. Opposite means if this is negative, then this one is positive. And I did the reciprocal, like I flipped them. So if their slopes are opposite and reciprocal, means the lines are perpendicular to each other. Okay. So let's do this equation. I think this is the last example that we have here. And let's try. Find equation of the line. Again, they said equation. Remember, y minus y1 equal mx minus x1, and we will end up y equal mx plus b, and this is what we need. Line that contains the point, I would say x and y, and is perpendicular to the line. This graph the two lines. Okay, now too much information in this one. They said perpendicular, which means their slope supposed to be reciprocal and opposite, but we don't know what the slope is here. So let's change this to y equal mx plus b, subtract x, cancel. I'm left with 2y equal -x plus 2. I switched their places, okay, because I like my mx first, like that one. Divide everything by 2. Y equal -half x, because we have that invisible 1 there, and you simplify, I get 1. So that's my y equal mx plus b for this line. And since the line they want me to find equation for is perpendicular to that one, so the slope of that line that I'm looking for is going to be positive, because opposite, and reciprocal, which means 2/1 or just a 2. So we have already a point, so let's try use your y minus y1 mx minus x1, plug in. What is y? -2. Okay, equal the slope is 2/1, x minus x1 is 1. Change this, y plus 2. You can write this as a 2, right? It doesn't mean that it's wrong. You distribute that. So 2 times x is 2x. 2 times -1 is -2. Now subtract 2 both sides, because I need to get the y equal mx plus b, remember? So because I'm looking for an equation, 2x minus 4. Their intercepts, of course, different, but their slopes are opposite and reciprocal. Okay, if I want to graph these, let's graph this. I'm going to move that over here so I can see both of these equations. Okay, let's graph. Come on. Okay, let's graph this. First, let's graph that one. This is +1. The y-intercept is going to go first, right there. And I'm falling 1 and running 2 because it's a negative slope. So fall 1, run 2 to the right. Here we go. Connect the dots. Oh, never mind. I clicked the wrong side. So just draw. Here we go. Okay, now let's graph this one. -4 is a B, and I'm going to graph that first. 1, 2, 3, 4 on negative y-axis. Slope is positive, so I'm rising and I'm running to the right. So I'm rising 2. 1, 2. How many times I'm running? 1. Because remember there is 1 there. So here we go. So I can connect these. And if you can tell, they're making 90-degree angle with both of them. So they are perpendicular to each other. Okay, that's how it goes. Guys, if you have any questions, please make sure that you comment below. I will help you with a specific question that you have. Like my videos and subscribe. Thank you so much. Bye.